man. I had such a hard day at school today.
I know what you need. You need a nice bag of chips. And in the process of eating these chips, I can teach you about the Unit Circle.
Wow! What is the Unit Circle?
Let me tell you, the Unit Circle is the greatest thing God has ever given us.
I love God.
Okay then, on to the Unit Circle.
On the unit circle, the angles in degrees are incremental. The five main angles are 0, 90, 180, 270, and 360, and that is one full revolution. In the first quadrant, the angles are 30, 45, and 60. In the second quadrant, the angles are 120, 135, and 150. In the third quadrant, the angles are 210, 225, 240. And finally, for the fourth quadrant, the angles are 300, 315, and 330. I forgot to tell you guys about the fascinating secant, cosecant, and cotangent.
Sweet Jesus, I love those. Let me tell you all about them. The cosecant, secant, and cotangent are the inverses of the sine, cosine, and tangent functions. They are literally 1 over any of the trig functions. Cosecant and sine are inverses. Cosine and secant are inverses. And cotangent and tangent are inverses.
Okay, so to learn about the angles, the special angles and radians, so for the first quadrant, all the angles, so they go 6, 4, 3, so like 30 is a 6, 45 is a 4, and the 60 is a 3, and so all those are just, the numerator would be pi, so for 30 it's pi over 6, 45, it's pi over 4, and for 60, it's pi over 3. Okay, so for the second quadrant, the special angles are 120, 135, and 150, and those three go in 3, 4, 6 for the denominators. So for 120, it'd be all the numerators are 1 less than what the denominator is. So if you know it's a 3 as for 120, you know it'd be 2 pi over 3. Then for 135, you know it's a 4, so it's 1 less than 4, so it's 3 pi over 4. And then for 150, it would be 5 pi over 6. Okay, now into the third quadrant. All the numerators are 1 over the denominator. And so for the third quadrant, it goes 6, 4, 3, so 210 would be a 6. And when I say 6, 4, 3, I mean the denominators go 6, 4, 3 for their special angle. And so 210 would be denominator 6, so it's 1 over, so it's 7 pi over 6. 215 is 5 pi over 4, and 240 is 4 pi over 3. Now onto the fourth quadrant. For this one, all the numerators are 1 less than double the denominator. And so for the denominators, it goes 300 is 3, 315 is 4, and 330 is 6. And so for 300, double that. 300 is 3, so double that is 6, and 1 less than 6 is 5, so you get 5 pi over 3. And then for 315, the denominator is 4, and so you double that, you get 8, and then you subtract 1 from it, and you get 7 pi over 4. Then for 330, you get 11 pi over 6. You're probably wondering why I did not mention the 0, 90, 180, 270, and 360 special angles. So for 0, it's just 0. For 90, you know that 180 is pi, and so that 90 is just half of what 180 is. So 180 is pi, and so that means that would be pi over 2. And then for 270, you know that it's just 1 more pi over 2 added to pi, and so that would make it 3 pi over 2. And then 360 is also another pi over 2 added to that, so that would make it 2 pi.
Special triangles are what we use to find the sine and cosine of all special angles. They are the backstory on the unit circle, special angles. There are two types of triangles in the unit circle, the 45-45-90 triangle and then the 30-60-90 triangle. We use the triangular shaped chips to show this. The 30-60-90 triangle is used twice, one for the 30-degree special angle and all of its reference angles, and the other for the 60-degree special angle and all of its reference angles. Then, the 45-45-90 triangle is on its own, representing the middle 45-degree special angle, or all of its reference angles. The special angles that are given to the special triangles are between root 3 over 2, 1/2, for the 30-60-90 triangles, and root 2 over 2 for the 45-45-90 triangles. To figure out these two special coordinates, we use an acronym, SOHCAHTOA, meaning sine opposite hypotenuse, cosine adjacent hypotenuse, and tangent opposite over adjacent. For the 30-60-90 triangle, the side lengths are 1x, 2x, and the hypotenuse x, root 3. Hypotenuse over root 3. So sine would be root 3 over 2, going opposite to hypotenuse. For the 45-45-90 triangle, the side lengths are each 1. So doing sine, it would be 1 over root 2. And then when it's rationalized, it would be root 2 over 2. So for sine, let's say pi over 4 or 45 degrees on the unit circle, the coordinate would be root 2 over 2.